scene of background. This is a pickup from background processes.
Background processes. Okay, we'll just put the slate down, and then I might just touch my shot up a little bit.
Sure.
Let's see. And great. Just look right at the lens.
Mm-hmm.
And this is terrific. Just gonna tilt up a tiny bit. And anytime.
So the next topic we'll explore is background processes. Mobile phones provide a really unique way to engage with the user by running computation in the background. For example, your application might show something when they get to a certain location, like in our story place example that we talked about in Module 1. You could also have set timers that go off to tell people when a certain event needs to happen or remind them of a specific interaction that they can take in your application. You can also use push channels to get information from the web onto your mobile phone and then notify users of that via a background process. Or use a push notification to trigger some background computation that you can perform on the mobile device. You can use timers to wake up a particular process at a specific time. And if you do this, don't forget to set a wake lock, especially on Android, so that then you can perform your computation, keeping the phone awake while you're running in the background. This can be really helpful if you're a cloud storage app, for example, and you want to back up photos that the user's taken. Maybe once an hour, your process can wake up, see if the user's taken any new photos, and then upload those photos in the background without any specific user involvement. However, on iOS, you're much more limited to what you can do in the background. You can play music, and if you use location, you can get periodic location updates from the platform. But iOS prohibits you from running sort of any arbitrary code that you want to run in the background. You can use the UI background modes to say that you want to get updates to location or have other background time at predefined intervals. But you can then only execute code for a short amount of time after getting these background processes activated. Background processes allow you to build an application that's responsive based on a user's context. If a user goes to a particular place or performs a particular action, then your application can deliver a notification or send data on the network to change the state of their interaction. And this enables really unique mobile applications and interactions that wouldn't be possible when you were dealing with just a static web page that a user might interact with, or a desktop application that just sits on their desktop and they can only interact with at a specific time. So really think about how background processes could be useful in your application and how you can use those to continually engage users, to continually keep data up to date, and increase the responsiveness of your application by fetching data in the background and caching it locally so that you'll have it always available when a user needs it. The next thing that we'll be talking about is notifications. Notifications have become a ubiquitous way to engage users in a mobile experience, to tell people that there's new content available, to remind users to engage with your service again, to tell someone that something really important has just come in, that there's breaking news, or that they have an email from their manager that they need to respond to right away. And notifications can also give location or other context-specific recommendations or actions. They could remind you to check in on Foursquare or Swarm. They could give you the most popular dish in a restaurant, or the latest recommendation or review for a place where you are right now. Or they can tell you about local transit, when the next train is going to come, when the next bus is going to come. All of these sorts of information can be delivered via notifications on the mobile phone. And a notification can be triggered in two ways. The application can trigger itself based on a timer or based on something that it's come up with in a background process, or a notification can come through a push connection from a server. And if a notification comes through a push connection, the server might say that you have a new message available, or it might show that there's new content available from your friends or breaking news, and send that message down to the mobile phone where it could be processed and a notification could then be shown to the user. However, notifications can also be annoying. especially if you're sending too many. And you have to consider this when you're deciding which notifications to send to a user. And there are also differences between different platforms. On iOS, you have to explicitly ask a user if it's okay to send push notifications. And they can say yes or they can say no. Where on Android, that's part of the default permissions that all applications have. So we've observed, for example, on iOS, only 58% of users enable notifications for their email, presumably a really important service in their life. So if you're building an app on iOS, you have to assume that some good percentage of your users will say no to push notifications. And if you do decide to use push notifications on iOS, make sure you clearly explain the kinds of things you'll be pushing before you ask for that permission, because then users are more likely to feel okay with what you'll be sending them and feel that they won't be overloaded with a lot of spam notifications or notifications that just say, hey, come back to this application, like a lot of games do. Also on iOS, notifications tend to go into this kind of black hole of the notifications list that users don't go back to and look at very frequently. Whereas on Android, notifications each can put an icon up in the top notification tray, and you can always see which applications are requesting your attention and are telling you that new content is available. So think about that when you're designing your notification strategies, and you might want to actually design something different for iOS versus Android. Which brings us to our final point of OS-specific differences. If you're building a multi-platform app and looking to build it both on Android and iOS, don't simply build the same app with the same set of screens and same interactions for each platform. Each platform has its own conventions, its own interaction styles, and its own best practices. So if you're designing for iOS, look closely at Apple's style guide. Make sure you're following their recommendations for navigation between different aspects of your experience. And if you're on Android, look over the Android style guide. Look at their recommendations and look at the way that you navigate between applications and screens. Android also allows you to launch screens and other applications via intents. And that can be a great way to promote sharing information to other applications. For example, if you're a photo application, you can have easy sharing via Facebook, email, messaging, just with a couple lines of code to say that you'd like to launch an app that can share a picture. And you can leave it up to the user to pick which app they would like to share to. So think about the differences of the different platforms in the way they handle background processes, notifications, and interaction flow, and make sure you're really creating the best application for the platform that you're developing on. Next week, we'll be talking about specifics of location and networking, and how you can develop an application that really fits into a user's context and provides responsive services based on the network conditions that are currently available.
That was awesome. I'm going to just loosen the shot once, and I just want you to tell me about next week.
Sure.
Because then it will feel like we're closing on
Yep.
a line.
Yep.
At the end of the newscast. You don't even have to slate it. It's fine.
Okay.
And tell me about next week, sir.
Next week, we'll be covering location and networking, and what you need to do in your application to make sure that it best suits the user's current context and the network conditions they have available to provide a responsive, context-aware user experience.